Hello everyone and welcome back to another video. So today's video is going to be a little bit different than my previous videos. We're going to be taking a look at the storms today. And we do have a storm firing off here in southwest Texas here. It does have a special weather statement on it. As you can see here, we have the special weather statement here in southwest Texas. And it is in a mesoscale discussion, meaning it's in an environment that the Storm Prediction Center feels the need to talk about to see if they're going to issue a watch. And that's what the point of the discussions is right now. I do believe we have a severe thunderstorm warning somewhere. Northwest Virginia. Oh yeah, there's also a secondary risk out this way. But this is not the primary risk, it's only a marginal risk. We have an enhanced risk for some of these areas here, as we're going to see in a minute. But this discussion here across northwest Texas says isolated severe storms possible this afternoon or early evening. Large hail and severe gusts are the main hazard, with tornadoes not being too intense. Probability of wash issuance 20%. And then we go to the other mesoscale discussion, and it is risk of supercells capable of all hazards here across the Texas Panhandle and southwest Oklahoma. And so we're going to look at the meso-analysis here. They said that this was the primary area here to watch for right in this area. And let's see, what data is this? Surface pressure and wind. Pressure and surface wind. So this is at the surface. We have a nice strong southerly flow that will be advecting moisture into the region. We do have some storms starting to form in that region of concern. If we look at bulk shear, in this mesoscale discussion, we have the highest pocket of bulk shear here. If we look at the Cape surface base, we also have pockets hanging around in this mesoscale discussion here. And then if we look at the supercell composite, we do have heightened area here across the mesoscale discussion. But the southwest is also not to be ignored, as we could have some strong winds and some very large hail associated with these storms. So if we look at, let's see, surface upper air, the 925 millibar analysis, we still got southerly flow in the low levels, increasing the low-level jet. And then we have 850 millibar low-level jet as well. A nice moisture being brought up into the region. 700 millibar analysis, still some low-level jet, although its winds are starting to shift a little bit from the southwest. And then if we look at 500 millibars is when they finally really start to shift from the southwest. And then we also have 300 millibars, which they're really starting to shift from the west-southwest. And so we do have some nice shear there. Wind shear, I wonder if they have hodograph map. We have some nice curved hodographs across the region here. Really nice curved hodographs in southwest Oklahoma. Wow, this is really nice curved hodographs. Let's see. If we look at downdraft Cape, we really have a lot of wind threat for these areas, the primary wind threat. And then along here is our primary wind threat. So we just have some isolated pockets of wind threat, although there is a greater, broader wind threat across the region. Theta elevation, let's see, surface. 3-hour dew point change. We've seen that kind of grow here across towards the Red River here. It hasn't shrunk too much here across central Texas, not a lot, but we do have this dry line setting up. I mean, if you look at this is just in 3 hours, the dew point has dropped by 20 degrees here. Just the past 3 hours across southeastern New Mexico. And this dry line, as it advances, is going to be a hot spot It's going to be a hot spot. How do I get out of this? Oh, that's pretty interesting. I didn't know you could do that. Oh, click top banner. Okay, there we go. So if we look across this mesoscale discussion area here, we have some really, really nice CAPE in the equilibrium level. It's also really, really high up in the atmosphere. The equilibrium level is where your partial ascent path, here, this dotted line here, and then where your temperature gradient and your partial ascent path cross here. Because after this point, the air becomes negatively buoyant, meaning it cannot rise any further. So this is about how high the storms are going to be, so close to 200 millibars in the atmosphere. And also, if you look at the wind profile on the right, you've got some nice deep layer shear out here. And then we also have curving of the winds in the lower levels here. If we look at the hodograph, we have nice curving. We have nice curving here at the lower levels, and then we got our deep layer shear out here. And then, let's see. I think that's the right moving supercell vector. Or this is the right moving, so this way, okay. But yeah, we also have some nice moisture up through the levels of the atmosphere, all the way up towards the equilibrium level. Now, there is some rare instances, whenever you have really strong storms like expected today, where we can get a thing called an overshooting top. So here's your cloud top on the SQT, but sometimes when the updraft is so strong, it can punch through the updraft. The updraft can punch through the equilibrium level, even if the equilibrium level is that far. It's because of the fact that updraft is so strong. Also, I am getting alert that there is a severe thunderstorm warning. Oh, it's probably that one. Anyways, however, if we move down here towards southwest Texas, we have a little bit of a cap in the atmosphere in place, and the equilibrium level is a little bit lower than it would be in northwest Texas. We also have a little bit of a cap in the atmosphere just below the 700 millibar level. We do have all these curving winds in the atmosphere. So when we look at a hodograph, we do have the nice curving winds. However, we just don't have the lower level CAPE. I mean, it could overcome it technically, but if it does not overcome the cap, then it's gonna, then the storms are not going to be able to initiate. Let's see. So we have 1800 surface-based CAPE, mixed layer CAPE at 1400. Most unstable CAPE is this value here. So it's really interesting. So if we go to this here, the reason I made a video is because they put a 10% SIGTOR, significant tornado risk here. As you can see, the SPC is outlining their new 5% significant intensity, which is EF2 plus tornadoes possible, strong tornadoes possible. Let's see, the wind threat hasn't been increased, and then the hail threat up to a 30% significant risk. So if we look, let's see, where was that? It was across it was across this mesoscale discussion area here, the greatest risk. And yeah, looking at that SQT, it's really favorable. I don't even know if there really is a cap. And I mean, look at this curving in the winds. This would create a nice hodograph here. Let's see. Yeah, it really does. We have the curving of the winds, and then we have the tail here. We have let's see, so the lowest level, the winds are going this way. So I think this is south, I believe. Or coming from the south, I'm not sure. I can't remember. And then we have this level right here. Then we have this level of the atmosphere here. Then we have this level, and then we had the final level somewhere out here. So I mean, look at the curving of the winds here, as we could see on the SQT. I mean, look at this, nice curving winds. However, if we move out here towards West Texas, the reason they're not in much of a risk today is because of this environment that is really not have a lot of cape and really dry. So, not really supportive of severe storms. Let's look at surface observations. And is there a way we could take this off? Surface observations. Okay. So as you can clearly see where we have the dry line setting up, 16 dew points here, 45 dew points here. This is obviously where our boundary is going to be setting up somewhere along this line here. And storms really like these kind of boundaries. We have a dry line setting up here, and this is the symbol for a dry line, just in yellow. It looks similar to a warm front with these like semicircles, but it's a different color. It's yellow. So we have this dry line here setting up with, and also you can definitely see the wind shift here. We have winds out of the southeast and south here in front of it, and then back to the west of the frontal boundary, or the front here of the boundary, we have winds out of the southwest, so southwesterly flow. So yeah, that's a good indicator of the boundary as well. So yeah, you can generally see we have the boundary somewhere in here setting up. Let's see. If we go see surface, does it have the boundaries? I don't know if it has the... it must not. It must not have the boundaries on here. That's interesting. But yeah, the SPC Day 1 outlook. Let's move to the... Let's move to the storm relative velocity surface to 1 kilometer. You could see just outside and just inside of that enhanced, we do have that in heightened area of SRH. Let's see, and then let's see, wind shear storm relative velocity 0 to 3 kilometers. We have this nice pocket as well here. So everything really lining up to be a good day for severe weather. Let's see. National Weather Service watches in mornings. Yeah, obviously you want that. I don't think they've issued the watch yet, and yeah, they have not. I wonder what time the mesoscale discussion is over. What time is it over at? No, get away with that thing. What is that thing? 80% chance of a watch being issued, 100 to 130 mile per hour tornadoes. So, potentially strong tornadoes. Let's see, it is till 22 and 00Z. So this would be, let's see, so it's GMT -6, so it should be 4 p.m. and let's see, 4 p.m. and 6 p.m. So right now it's the prime time for severe weather ramping up. Let's close this thing. What is that? 1.5 inches to 2.5 inch hail and 65 to 80 mile an hour winds with tornado peak intensity up to 130 miles per hour. So very, very large hail, very, very strong winds, potentially strong tornadoes as well. Let's see, that thing up there. Yeah, tornado possible, actually. That's pretty crazy. But anyways, let's get back to, let's see. significant tornado parameter. We do have that elevated risk here. Supercell, less moving supercell composite. I would imagine it'd be higher down here to the south. Yeah, we also have a heightened area here. Let's see. Non-supercell tornado. Essentially none except down here. Violent tornado parameter of 2 across central Oklahoma here. That's pretty interesting. So moving on here, let's see what the NAM thinks of the day. So it does show storms really starting to fire off here. Let's see, this is around 22Z, yeah, 4 p.m. So about right now, it's wanting to show storms firing off. It's wanting to show a little bit of a line of storms trying to form, but we also have these discrete cells all over the place here. And then it shows them dying down and becoming an MCS, and then it shows really all the stuff being east of this by Saturday, day 3. And then, let's see, it has it really moving off as a MCS by 20Z on Saturday, which is 2 p.m. This is 3 p.m., 4 p.m. We start to see some more convection form. But yeah, that's about it. So thank you all for watching today's video, and I will see you in the next video. Bye.